Here's a question for you. When you think about regulatory compliance, all the rules and laws that businesses have to follow, what percentage of the professionals in that field do you think have heard of one of the most powerful new AI technologies, the agentic workflow? 80%? 50? Try less than 10. A recent survey found that a staggering 92% of compliance professionals had never even heard the term. 9 out of 10. And yet, this technology is already starting to completely revolutionize not just their field, but engineering, software, and the very nature of how we build our digital world. Hello and welcome to Mindcast, the podcast that decodes the future. I'm your host, Will, and today we are diving deep into a topic that sounds technical, but I promise you, its implications affect every single one of us. We're talking about the end of an era, the era of move fast and break things, and the dawn of a new one defined by something called agentic workflows. Today's promise is this. By the end of this episode, you will understand this fundamental shift in how we create technology. You'll see why the chaotic, breakneck speed of the last decade is giving way to a new kind of rigor, a new discipline supercharged by AI. And you'll understand the new role that we, as humans, are destined to play in this future. So, let's get into it. For the better part of 2 decades, Silicon Valley and the tech world at large have worshipped at the altar of move fast and break things. It was a philosophy that prized speed above all else. Ship the product, get market share, and worry about the messy details later. And to be fair, it created trillions of dollars of value. It gave us the apps, platforms, and services that define modern life. But it also created a crisis, a slow-motion disaster. We are now living on a digital infrastructure built on a mountain of finicky, insecure, and poorly performing legacy code. Think about it. The buggy apps that crash, the security breaches we hear about daily, the systems that are so complex and fragile that companies spend billions just to keep them running. This is the hangover from that 10-year-long party. That technical debt has come due. Now, in some fields, this was never an option. You can't move fast and break things when you're designing a flight controller for an airplane, or an implantable medical device, or the software that runs a power grid. In these safety-critical systems, rigor isn't a nice-to-have, it's a matter of life and death. For years, there has been this massive philosophical divide between the slow, meticulous world of systems engineering and the chaotic, agile world of software development. And then AI code assistants showed up. At first, it seemed like they were just going to pour gasoline on the fire. They allowed developers to produce even more code, even faster. They empowered us to break things at an unprecedented speed without adding any of the underlying discipline or architectural thought. It was a recipe for creating more of the same problems, just on a much grander scale. But then came the shift. The move from simple AI assistants to agentic workflows. So what's the difference? It's everything. A simple AI assistant is like a calculator. You give it a prompt, it gives you a chunk of code. An agentic workflow is like a fully autonomous, highly disciplined engineering team. Imagine a system with 2 layers. At the top, you have the orchestration layer. Think of this as the ultimate project manager. It's a deterministic, rule-based engine that enforces the process. It says, you cannot write the code until the requirements are finalized. You cannot deploy the system until all security checks and tests have passed. It enforces a level of procedural discipline that humans, under pressure, often skip. Beneath that manager, you have the execution layer. This isn't one giant AI model trying to do everything. It's a collection of highly specialized agents. There's a requirements agent, an architecture agent, a coding agent, a testing agent, and even a critic agent whose only job is to review the work of the others. These agents work together, each with a specific job, all governed by the strict rules of the orchestrator. They don't just take a vague natural language prompt, they operate on a structured, machine-readable specification with a clear definition of done. This is how agentic workflows reintroduce Rigour, They bring back the discipline of traditional engineering without sacrificing speed. In fact, they accelerate it. A pilot study at Cisco on debugging workflows found that this approach led to a 93% reduction in the time it took to find the root cause of a problem. That's not a small improvement, it's a revolution.
But, of course, it's not a perfect utopia. With this incredible new power comes a new set of incredibly subtle and dangerous problems. The first is what the industry is calling the 80% problem. AI agents are fantastic at generating the first 80% of a solution, the basic functions, the user interface, the standard API calls. This code looks great, it works in a simple test, and it gives a powerful illusion of progress. But it's the last 20% that makes a system production-ready. The hard stuff, the graceful error handling, the retry logic, the circuit breakers, the security measures for edge cases. These are the non-functional requirements that agents, left to their own devices, almost always forget. They build a beautiful car that runs great on a sunny day on a straight road, but they forget to install airbags, seatbelts, or anti-lock brakes. The result? The system looks perfect right up until it scales, hits a weird edge case, and catastrophically fails in production.
This leads directly to a far more insidious issue: comprehension debt. We all know about technical debt, messy code that's hard to work with. Comprehension debt is different. It's the silent, growing gap between the sheer volume of code in a system and the amount of that code any human on the team actually understands. The code base looks clean, the tests are all green, but no one can explain why a foundational design decision was made, because it was made in a fraction of a second by an agent. When the system inevitably breaks, engineers have to spend hours or even days just mentally reconstructing the AI's intent before they can even begin to fix the problem. One survey found that 45% of developers report that debugging AI-generated code is more time-consuming than debugging human code. The time saved in generation is lost with interest in maintenance. This is the great paradox of AI-assisted development right now.
So if we can solve for those challenges, what does this new world look like? This is where it gets truly mind-bending. We're seeing the return of something that has long been considered the holy grail of engineering: formal methods. What is that? It's the process of using mathematics to prove that a piece of software is correct. Not just testing it, but writing a mathematical proof that guarantees with absolute certainty that entire classes of bugs or security flaws cannot exist. For decades, this was considered too slow, too expensive, too academic for anything but the most critical systems, like nuclear power plants. Agentic AI is changing that equation entirely. We now have AI proof agents that can collaborate with symbolic theorem provers. The agent tries to write a proof, the theorem prover rigorously checks it and provides feedback, and the agent reflects on that feedback and tries again in a tight loop until the proof is verified. We're already seeing this in the real world: pipelines that can analyze a software library and mathematically prove the absence of certain runtime errors. This isn't just about building things faster, it's about building things that are demonstrably, mathematically perfect.
And this leads to the most important question of all. What does the human do in this new world? If agents are writing the code, running the tests, and even proving the software is correct, what's left for us? Our role isn't disappearing, it's elevating. It's moving from craftsmanship to architecture, from writing lines of code to defining the systems in which the agents operate. The engineer of the future is less a line-level coder and more a systems mathematician. Their primary job becomes writing hyper-strict, unambiguous specifications. Their value is in auditing the assumptions the AI is making, reviewing the theorems the AI has proven, and ensuring that the mathematical correctness of the system actually aligns with the human intent behind it. The human becomes the guardian of the system's why. They're the ultimate backstop, the final verifier. And paradoxically, human review has now become the single biggest bottleneck in this hyper-accelerated new life cycle. The market value is no longer just in our ability to create, but in our expert ability to verify.
First, adopt a vibe, then verify mindset. This is a brilliant phrase that's emerging from the systems engineering community. It means we should treat AI-generated output, whether it's code, an email, a design, or a research summary, as a highly sophisticated first draft. It gives you the vibe, the direction, the initial structure at incredible speed, but it is not the final product. The most critical work, the work that requires deep thought and context, is the verification step. Our role is shifting from the creator of the first draft to the rigorous editor of the final masterpiece. Never trust, always verify.
Second, we must architect for failure, because the failures are getting weirder. The old world had syntax bugs and crashes. The new world has silent, cascading failures. An agent can make a subtle logical error early in a long chain of tasks, and that error gets passed downstream, treated as truth by every other agent that follows. The final output looks plausible, confident, and completely wrong. This is why we're seeing the emergence of new governance frameworks that act as an immune system for the agent swarm. They enforce things like automated rollbacks. If the system detects a logical inconsistency or a cascading hallucination, it doesn't wait for a human. It instantly halts execution and reverts to the last known good state. We have to build the safeguards directly into the architecture because we can't rely on spotting the failures with our own eyes. Third, and finally, we must embrace our new role as systems mathematicians. Even if you're not a programmer, this concept applies to you. It means that our most valuable contribution is no longer in doing the task itself, but in defining the task with absolute precision. In a world where agents execute instructions literally, ambiguity is the enemy. The ability to create a hyper-strict specification, a clear, unambiguous, and well-constrained set of instructions is becoming the most valuable human skill. We are moving from being the workers to being the architects of the work. The era of move fast and break things is over. It was a necessary, if chaotic, chapter that built the world we have today. But the world we are building now requires something more. It requires a return to rigor, a new discipline, not in opposition to the speed of AI, but in partnership with it. The future isn't about choosing between speed and perfection. It's about using one to achieve the other. Thanks for tuning in to Mindcast. We'll see you next time.